Lesson 8 DHCP Dynamic Host Configuration Protocol. In this video lesson, guys, I'll show you how to make basic configuration of DHCP protocol on Cisco routers and not so basic configuration, including IP version 4 DHCP and IP version 6 DHCP. And first of all, we have to define what for DHCP server is used. DHCP protocol and DHCP servers are used. Imagine that you are entering into the building of the university or any mall in your country, and you turn on your laptop, or maybe you're turning on your smart device like smartphone, and you turn on the wireless adapter. And afterward, if there is no problem with authentication for the wireless, for the Wi-Fi network, after a while your computer is able to communicate with other equipments in this network, and also it's able to reach the internet. So somehow your equipment is connected to access point, and access point is providing you ability to communicate with the internet like this. So you know that we are working with the IP protocol to reach the internet, and due to that fact that we are working with IP protocol, our equipments have to have IP address before they will be able to have communication with the other equipments, including our local area network and including World Wide Web. And to have a proper IP address, you have two variants how you can provide this IP address. You can statically make configuration of your IP address, or we may say it's like a manual configuration. And another variant which you can use, it's like dynamic configuration, so with the help of the DHCP protocol. So let me show you how you can make configuration of IP address manually. And here it is. So you can obtain IP address automatically, or you can provide IP address, for example, manually like this. So you can provide the information about subnet mask, and also you can provide information about the default gateway, also including your information of the DNS server. Or if you'll click the button of like a ratio button to obtain IP automatically, then your computer will try to contact the DHCP server, and in case if it is configured properly, and if you have the DHCP server which is reachable by a computer, then it will provide an IP address for your computer. So what kind of information can be provided by DHCP server? By DHCP server, you can gain the IP address of the computer. Additionally, DHCP server can give you is giving you the subnet mask, and optional, it is giving you the information about your gateway, the file gateway. Optional, it is giving you information about the DNS server's IP address. And DHCP server provides all this information for the limited time. So it's called leasing time. And after a while, if your computer is not connected to the network, DHCP server will can give this information, the same IP address which it gave to you before, after a while it can give it to another equipment. So how DHCP communication is happened from your laptop, from your end device to the DHCP server? First of all, when you are turning on your equipment, and in case if your equipment doesn't have an IP address and you're saying that find out DHCP server, so you are not actually saying that find out DHCP server. All what you do, you are just entering to the configurations of your equipment one more time. And for example, in my Wi-Fi connectivity, so I'm just clicking to obtain IP address automatically. And then my computer have to find the DHCP server. But the problem is that my computer doesn't have IP address. So without IP address, my computer is not able to contact with the DHCP server directly. So that is why my computer have to make a DHCP discover packet, which will be directed to the broadcast to all the network equipments which are reachable by my computer. And the request is looking like I would like to request an address. And then our server, if my server is reachable, my server is giving a DHCP offer, which is sent to me by unicast due to that fact that when I sent this packet, I had here source MAC address, which was MAC address of, for example, of AAA, and there was destination MAC address which been listed as FFF, whereas FFF MAC address is defining the broadcast. And then after my request came to server can reply to my MAC address so that there will be written information. Source MAC address is the MAC address of our server. For example, MAC address is BBB, and destination MAC address is going to be MAC address of my equipment, and it is sent to me directly. Well, and when server is giving the reply, a reply is actually the offer. I am DHCP server 1, here is an address I can offer to you. And afterward, our equipment can make the DHCP request by the broadcast again, so that our computer is sending information by broadcast, not because of the second time it is happening, not because of our computer doesn't know the MAC address of the DHCP server. It is done to tell to all other equipments that, to all other DHCP servers, in case if they are existing in the network, so that they will understand that our client is going to work with the server which has the MAC address BBB. It is like request for one server and deny of their offers to other servers. It's like, this is my client and I have in the network some DHCP servers. So my computer made up the broadcast request. The request came to all these 3 servers, and then in the second step, all DHCP servers can provide an offer which will reach my computer, and all these offers will come to me, to my computer, and my computer will provide the broadcast reply. Is going to be DHCP request to all the servers. It will come to all servers and it will reach, for example, it wants to make a request for this server, which is BBB, but my computer is sending this DHCP request to all the servers so that all servers will understand that their offers are declined. And whereas DHCP request is actually like, Yes, I want to get this IP address. Can you give it to me, please? And then DHCP acknowledgement packet is generated by the server, and it's like, you know, acknowledgement. Alright, so you are owner of this IP address, you are owning or you are leasing this IP address for a limited time. And also you have to know that DHCP message sent from a client which is using the UDP source port number 68, here it is, and destination port is 67. And DHCP message sent from server to client use DHCP UDP source port 67, vice versa, and destination port is 68. And what else we have to say? When our client is making the renewal process of the IP address, renewal of the lease, our client is sending only the unicast request message, and our server is sending the unicast message as DHCP acknowledgement. It's like you know that when our server is giving us the IP address for a lease, it is giving it for a limited time. For example, DHCP server got timer with the lease time, for example, 2 hours. After 2 hours, our computer, if it is not connected to the network anymore, then after 2 hours, the same IP address which being given to computer AAA to my client can be used by different equipment. But in case if my computer is connected to the same network and still working, then my computer will make a renewal request, DHCP request, which will say that I would like to renew my lease, so that our server will say that alright, so you can still use this IP addresses. And but in case if you will turn off your computer, and if you will if your network interface card, your wireless network interface card will be reloaded, at that moment your computer will try to find the DHCP server one more time, and then this DHCP operation initial will be happening one more time. But in case when your DHCP server already known by you and you are still using this IP address, your computer will just send one request and it will get one reply. DHCP message format. Well, we have the message format, which has some different fields, including field which is called OP, which is defining the operation code. OP specifies the general type of the message. For example, a value 1 indicates a request, and value 2 indicates the reply for the message. We have hardware type, identifies the type of hardware used in the network. And in example 1 is Ethernet, so it's quite enough to understand to us that 1 is Ethernet and 15 is the frame relay. We still don't know what is the frame relay, so that I just recommend you to just take a look for this value. It will be quite enough for you. Next one is the hardware address length. Specifies the length of the address. A number of hops controls the forwarding of the message, set by 0 a client before transmitting the request. Also, we have the transaction identifier used by the client to match the request with replies received from the DHCP server. We have also information about seconds. Identifies the numbers of seconds elapsed since a client began attempting to acquire a renew or lease or renew the lease. Used by DHCP server to prioritize replies when multiple clients' requests are outstanding. Also, we have a flags, which used by the client that doesn't know its IP version 4 address when it sends a request, and only one of the 16 bits is used, which is the broadcast flag. A value of 1 in this field tells the DHCP server or relay agent receiving the request that the reply should be sent as a broadcast. So we didn't speak about relays yet, soon we will do it. And also we have information about the client IP address. So the client IP address, or in abbreviation CIADDR, DDR, used by the client during lease renewal when the address of the client is valid and unusable, and not during the process of acquiring an address. The client puts its own IP version 4 address in the field if and only if it has valid IP version 4 address while in the bound state. Otherwise, it sets the field to 0. It means that when our computer wants to acquire, it means that when it wants to get the new IP address from the router, I mean from the DHCP server, it is sending the information about client IP address, which is completed all with zeros. It means that I want to get the new IP address. It's not renewal. But when our computer already have an IP address, for example, like this, and it wants to renew this IP address, it is placing it into the field of the CIADDR. Your IP address used by the server to assign an IP address to the client. So it is given in the reply. So when a reply comes from the server to client, it is saying that, look, you can get this IP address. Server IP address used by the server to identify the IP address of the server, and the gateway IP address defines the default gateway information. So here it is. So information about the server's IP address, information about the gateway address. Next is client hardware address. Next, server name used by the server sending a DHCP offer or DHCP acknowledgement message. The server may optionally put its name in the field This can be a simple text, a nickname, or a DNS domain name such as DHCP discover netacat.net, for example. Also, we have information about the boot file name, optionally used by a client to request a particular type of boot file in the DHCP discover message, used by a server in a DHCP offer to fully specify a boot file, directory, and the file name. And we have some options in the field of the DHCP option. Well, and here you can find out DHCP version 4 discover and offer messages in which our client is making a discovery process. It wants to find out the DHCP server, and as you see, the packet or the frame is sent to destination MAC address of the broadcast. It is defining the broadcast, and the source MAC address is the MAC address of computer A, whereas IP source is all zeros because we don't have seal IP address, and destination IP address is also defining the broadcast. Well, we have the port number 67, UDP port number 67, and client IP address 0, we don't have IP address, gateway IP address, subnet mask, and our client hardware MAC address is MAC address of computer A. Whereas the offer which is coming back from the server to the client will be with destination MAC address of computer A, with the source MAC address of our server, and with the IP source with the IP address of our service IP address, and IP destination is going to be the offer. Will you get this information or not? And here we can find out the same offer. Here we can find out the gateway, which is not given by the DHCP server by this example. In this example, it's all zeros. We can see here the subnet mask information too. How to make configuration of the DHCP server on Cisco router or Cisco switch. Well, we have to type, first of all, we have to define which IP addresses we don't need to distribute by the DHCP server. And we have to do it with the command of IP DHCP excluded address, and you can define list of address, or you can define just a single address. And for example, here we have to configure the DHCP server on router 1, and our PC1 is going to be the DHCP client. So that first of all, as you see here, we are defining that IP addresses, those IP addresses which we don't need to distribute. Why we are getting these addresses? Why we don't need to distribute them? Because at least some of them will be used, one of them will be used to define our own interface. And our own interface IP address is 192.168.10.1. So if our router will give this IP address to any client, then it will be duplicated IP address and it will cause a problem in the network. Also, we can have some servers in the network. For example, server will have IP address like 10.2. Another server will have IP address 10.3, and as you know, servers have to have a static IP address so that they can be reachable by their static IP addresses. By using this command, we are excluding those IP addresses which we don't need to distribute. Next, then we are creating the pool, IP DHCP pool command with the name LAN pool 1, for example. We are creating this pool, and then inside the pool we are defining which network will be distributed, and we are defining network address and its subnet mask. And also we have to pay attention that we are excluding these addresses. It means that first of all we defined that IP addresses like this from 10.1 till 192.168.10.9, and also plus address 192.168.10.254. These IP addresses will not be distributed by DHCP, but all other IP addresses from the network 192.168.10.0 with prefix 24 will be distributed by DHCP server. Then we are defining what will be the file gateway. So the file gateway will be IP address of our own interface, because PC wants the file gateway to exit from the network. It has to reach its own router's IP interface. IP address of DNS server, and optional, so this is optional actually. Optional. And this is also optional, and this is also optional. The information about domain name of our server. And what else? Now let me show you an example how to do it in the packet tracer. So let me close configurations. Alright. Okay, and let me open for you a DHCP IP version 4 laboratory work, which I prepared specially for you, and in which we have a basic topology with the DHCP server. So our DHCP server will be router 1, and our clients PC2 and PC1 will be a DHCP clients. So they will get IP address manually, automatically by the DHCP, by using DHCP services. So first of all, we have to be sure that we don't have IP addresses. We use static and we didn't give anything in configuration of the IP of computer. And then we have to check first of all, did we configure IP address on our router? What kind of configurations do we have in the router? First of all, I'll type the command show IP interface brief to be sure that my router get IP address by its own. And then I have to define, so in my plan, I have to exclude IP addresses which I will use for other purposes, not for clients. It will be IP addresses 10.1 and till 192.168.10 and 5, for example. I will use first 5 IP addresses for the default gateway and for the servers which will be placed in the network. And then I will do it by using command IP DHCP excluded addresses and 192.168. So if you'll take a look for the syntax, you'll find out lower IP address starting from this address 10.1 and then high IP address 192.168.10 and 5. Then I will create the DHCP server. So DHCP pool by using command IP DHCP and then the pool, and let me tell you, it's going to be pool number 1. So let me say that my pool or my DHCP pool, or the name is not so suitable, or DHCP pool. Then inside the DHCP pool configuration, I have to type first of all network. Which network IP addresses will be distributed? And they are going to be 192.0, and then I'm defining the subnet mask of this network. Well, next I can define the gateway or default router. It's the same as default gateway. It's going to be 10.1 because it's IP address of my own interface. And then optional, I can provide information about DNS. For example, it's going to be 192.168.10.5 because it is busy, and I say that I will not distribute these addresses to the clients. Well, that's it. I think that we properly configured our DHCP on the router, and now it's time to take a look for how our clients are going to take this IP address from the DHCP servers. So I just click it to DHCP, and then I can immediately see here that IP address is appeared here, and it's starting from 10.6 because I say that we made up configuration with you that is excluding IP addresses from 10.1 till 10.5. And also we can find out here information about the default gateway and information about the DNS server. Next, I have to do the same job here. I will just try to get these IP addresses, and here are they. And now it's time to check the connectivity between equipments by using generation of this packet, ICMP packet, source and destination, and now they are available to make communication between each others because DHCP server gave them IP addresses. And if you want to see your IP configuration of your computer, you can type IP config command, which is going to show you information, which IP address do you have, what is your default gateway, or you can type the command IP config all, which will show you detailed information about your IP configuration, including IP version 4 and including IP version 6 addresses. And in case if, so here we can see that this is simulation, this is not full like in real device. So but if you'll take a look for the CMD, you can type command ipconfig all command, which will show you all available network interface cards, and you will see that in my wireless network my computer has this physical address, and here is the name of my wireless equipment. By the way, it is supporting AC, it has to be very fast, and also I can see here information about my lease obtained, and I just took this information about, I took this IP address about 40 minutes ago from my DHCP server, and lease expires today at 1:19 after about 12, or not 12, sorry, about 16 minutes. My IP address will be dropped, my computer will try to make a renewal process, and it will say it will send the DHCP request to the server. So my DHCP request is like the information which goes to server and which is saying that, look, I still want to use this IP address. And here is my information about my IP address, subnet mask, and so on. This is how you can make the basic DHCP configuration. Let's continue with you. How we can verify DHCP configuration on our router. We can go to router, and in the privileged executive mode you can type the command show DHCP show, or maybe I have to type show DHCP IP DHCP binding, which have to show me which IP address is given by router to which MAC addresses. And for example, MAC address E4C5 took IP address, as we see from this table, 10.6. So let's take a look. This computer took 10.6 address, and we can learn its MAC address, which is shown here. So it is E4C5. So this information is correct. Now, alright, so we just can skip it. And also, like in packet tracer, we don't see here release expiration because it is just simulation. In real equipment, you will see the real data.